In this video, we're going to talk about how to use this VEX robotics course. You can see that there's these different topics listed here. Notice that over on the right here, there's reference, which really is the breakdown of the whole course. So if you click on that, you can see here's fundamentals, setups, movement, and so on. Here's all the videos that are contained in those different topics, as well as some reference videos here. And then you have a lot of other things that most of these are PDFs. So like the motion PDF and structure, those are two really important ones that we'll talk about a little bit later. And for instance, this first one, robotic building instructions for the cortex. So if you click on that, excuse me, and you get a PDF. And so that's the instructions on how to build this RecBot. This is one of the longer PDFs, about 39 pages, but it's really good. It gives you step-by-step instructions. Here's a bill of materials of all the parts that you'll need, and then shows you step-by-step how to build this particular bot right here. So that's really helpful. Okay, so let's just look at a couple of the, in each category we'll look at a couple of things. So for instance, the best way to go through this is just start from the beginning and go through each lesson step by step. I'm going to jump to this Robot C Rules Part 2, and you know, there's a video here.
You may have noticed that Robot C code tends to use a lot more punctuation than English. The semicolons used to mark the end of statement.
So that's very helpful. It's a video. Then there's questions that you can to test your understanding after you, and then usually at the end there's some other either PDF or you know, some other sample copies of Robot C code. So for instance, let me just switch over to comments. Right, so this is just it's a one-page PDF on how to put comments into a program. It's very nicely laid out. Or reserve words. So in other words, in Robot C, there are certain words that you can't use for variable names. They're reserved for different types of functions. And so there's some examples of them here. Wait 1 millisecond here. That's a function that you can use. So you can't use this name for a variable name, for instance. Okay, so next I'll switch over to setup. And again, as I said, the best thing is just to go through this step by step. If you want to build the RecBot, you click on that. If you're using the VEX Cortex, then you can just click on this, and this will give you a link to a PDF that you can download that we looked at just a minute ago. Okay, next let's look at movement. So here's a pretty neat challenge. So you can click on this, and it will give you a little video of the challenge. See, that's only like a 15-second video. So that was a pretty simple challenge to begin with. Let me just... Right, so you can download the PDF, and here's a description of how to set up the field. Basically, you want the robot to be able to drive, make a few turns, and end up parking over in this space right here. And this is used in the movement to go through a bunch of different topics on how to drive straightly, how to move forward a certain distance, automated straightening, right, even all the way down to PID control. So they're short videos, and you can watch them and then try the code with your robot, and it works out pretty well. It's very well. I think it's very well done. So I'm just going to look up here at motor power levels. So this is
You know how to make your robot move at full power in the forward direction. However, moving at slower speeds can help your robots to be more consistent. In this lesson,
so you can see that's like a 2-minute video, but you'll notice down here there's these RBCs, so those are Robot C documents. You don't want to ever click on the virtual robot. That you have to that's to run your program in a simulator, but you have to buy that. That's not something you can use. So if you click on this one right here, then you can look at that program. So some of the Robot C programs that you can download have the beginnings of some code, as you can see in this one, for the mind field retrieval remote start. But others of them just basically have task main. So in other words, you download the Robot C code, and for some of them there is a fair amount of code, like this one, this particular one I'm showing right here, and the control arm. They give you some code to start with, and same thing with mind field retrieval. But as I said, a lot of them, when you download them, it's just pretty basic task main, and you got to supply the rest. Okay, so if we move on to remote control, and there's this Mind Challenge video. Let's take a quick look at that. Okay, so if you wanted to do that challenge, you can download a PDF right here. And there's a 4-page PDF that you can take a look at, and gives you information about how to set up that challenge. So that would be something that you could set up and then use the RecBot to have your students actually compete with that. We can look at joystick mappings, and this video explains how to look at your code, how to set up code so that you can read what the remote control different buttons and joysticks are reading. So that's pretty good. And okay, and then we'll just take a quick look at controlling the arm, and just play a little bit of that.
in this lesson, we will work on the final part needed to compete in the Mind Field Retrieval Challenge, the arm. But first, here are some of the key features of the arm design. It can tilt up or down using a single motor plugged into port 6 on the microcontroller. Running the motor in the forward direction raises the arm, while running it in reverse lowers it. The arm relies on the positioning of the physical robot to put it in the right place to lift or lower an object. There's a limit switch in the front of the arm and a potentiometer along the shaft. You will learn how to program these sensors in the sensing section. Now that we've covered the basics, let's get to work in Robot C. Start by opening your Mind Field Retrieval Remote Start program and save it as Mind Field Retrieval Arm Control.
So now we'll go over to sensing, and you can see there's a bunch of videos here. Again, they're not very long, and they're very helpful. If I click on straight until near, right, and I'll just play a little bit of that one.
In the previous lesson, you implemented the basic forward until near behavior, but learned that there were a few imperfections in the system. One obvious imperfection is that the robot moves toward an object, but not necessarily straight toward an object. Moving straight is important if you want to stay on a specific track, or move up to an object like a mine to pick it up. In this lesson, we'll combine the forward until near behavior with the automatic straightening behavior, so the robot will actually move straight forward while no obstacle is nearby. This uses two types of sensors together, but isn't much more complicated than simply combining the two finished pieces. We'll just copy and paste the automatic straightening code from the Labyrinth AutoStraight program you made in the movement section and use it in the forward until near program. Good.
So I think that, anyways, that gives you a pretty good idea of just the way you can move through all these videos step by step. And again, if you want to just look at the list all at once, these are all the video lessons, right? So it's, and then, the other thing I wanted to mention was just two things that are really useful to look at are the motion and structure PDFs. So the motion PDF, you can download that one. That's 26 pages, but it gives you a pretty good idea without, using a lot of mathematics or calculus or anything. So a student like in 9th or 10th grade should be able to follow this pretty easy. Gives a description of different, the axles, gears, bearings, and then how you can use the different ratios in different size wheels, how they'll affect the way the robot runs. So here, in other words, if you drive a 36 tooth, if you're driving a 36 tooth gear, using that to drive a 12 tooth gear, then you're going to lose torque, but you'll increase in speed, and vice versa. If you drive at the 36 tooth gear with the 12 tooth gear, then you'll have more torque, less speed. So I think it gives you a kind of a general conceptual description of how that stuff works, and it's a good introduction without having to get into a lot of mathematics and the difference that the size of the tire makes and things like that. Okay, and then the other thing was on the structure. So the structure PDF, you can see that's 18 pages long and describes the different kind of structural pieces that you have and different kinds of hardware, and also talks about center of mass and stability. If you know where the center of mass is, then you can figure out if the robot is going to be a tip over if it tries to go up too steep of an angle, so it gives, I think, a pretty good explanation there. And then also how to reinforce a structure, maybe put in another support. So it's not too in depth in terms of stress analysis, but it gives you a little bit of an idea of how to put it together and keep the center of mass in a good spot. And as I mentioned, there are a lot of PDFs that give you some more example problems to work on. So here's just asking a student to move the robot at quarter speed for 1 second, followed by half power for 1 second, 3/4 for 1 second, and so on. So this is just gives you kind of the pseudo code, and this is something that a student can work on to try and practice what they've just learned. So here's another one, speed of sound, and you can see write a program that uses the ultrasonic rangefinder and to control the speed as it approaches an object. And you can try different variations, motor write speed, sensor values. So in other words, the sonar sensor might be giving you a value based in centimeters as you approach the object, or what happens so that distance decreases. But if you multiply it times 3, obviously you're going to approach it faster than if you're dividing it by 2. And then this has some questions, And then another challenge. What about if you have it, move towards an object and then decelerate when it gets close, and after it comes to a stop, back up. And this third one is just randomly turn a random number of degrees and then begin to drive forward again until it reaches another object, and then do the same thing again, back up, turn a random number of degrees. So it kind of step by step builds on the knowledge that you have on how to do the programming, and I think it does pretty good. And so this, again, this was all from the reference tab, and there's a lot of useful information here on the VEX potentiometers, shaft encoders, and so on. Two-wire motors, what the stall current is, what the stall torque, and how fast it will speed if nothing spin if the no load speed, how fast it will go if nothing's attached to it, and so on. And so I think just take your time and go through this stuff step by step. You can come out learning quite a bit. There's a lot of different PDFs and information here. So anyways, that's just kind of a general overview of this VEX robotics course.